Hey folks, today we are going to talk about mass-energy equivalence. To understand the importance of this discovery, we have to think about physics at the turn of the century. Scientists had just discovered radiation due to the work of Marie Curie, and they were pretty confused by what they found. It seemed that energy was emanating from radium for no reason at all, which seemed to break the rules of mass and energy conservation. Well, Albert Einstein came up with the equation E equals mc squared, that explained how mass and energy were equivalent, and that they were just different forms of the same thing. E is the energy of the total energy of a system, m is the relative mass of the system, and c is the speed of light, which functions as the conversion factor for the equation. We are going to try to explain the implications of this discovery as well as how it works. Harrison will help me with that.
Hiya guys, I have a couple of examples to help me explain how the equation E equals mc squared relates to matter and energy. First off, imagine that you have a pencil that has a mass of m. Therefore, that pencil has an energy of m times c squared. If you were to light a fire under the pencil, you would increase the total energy of the system by increasing the heat energy of the system. And at that point, if you were to solve for m, you would get E over c squared. If you were to increase the energy then, you would be increasing the mass, since this equation dictates that E is directly proportional to m. To understand why this works beyond this, imagine an ideal gas in a room. The total energy of this system, which consists of the gas, is all of the kinetic energies of the individual particles that make up that gas. That means that m is equal to E over c squared. If we were to heat up the room, increasing the kinetic energies of the particles, those particles would become harder to move. They are more resistant to changes in position, and they have more inertial mass as a result. Next, Dominic will show you some example calculations that explain this concept numerically, and will definitely help on the test.
Alright, imagine that you have an object that has a mass of 1 kilogram. Therefore, it has an energy of c squared, or 9 times 10 to the 16th joules. If you were to double the mass of the system to 2 kilograms, you would also double the energy of the system, and have 18 times 10 to the 16th joules of energy. The same works if you were to increase the energy. Since mass is equal to energy over c squared, an object that has a mass of 1 kilogram and an initial energy of 9 times 10 to the 16 joules, whose energy is doubled, now has a mass of 2 kilograms. If you noticed, a small amount of matter contains a huge amount of energy. Now Ashray will tell you more about how we can harness that matter and transform it into energy.
So current methods of producing energy work by converting only a small fraction of the mass of the fuel into energy. Now this is very inefficient, but it's the best we can do right now. In the future, however, antimatter reactors will allow us to convert the entire mass of the fuel source into energy. Because the entire mass of the fuel source is converted, the formula E equals mc squared works extremely well for determining the amount of energy created in a single reaction, as the conversion of fuel to energy adheres directly to this relationship depicted in the equation. Now by taking E equals mc squared and plugging in the mass of the fuel source for m and the speed of light for c, the amount of energy created will be equal to E. When compared to existing reactors, where the mass of the fuel converted is much lower, we can see the advantage of the antimatter reactor. These antimatter reactors can achieve this level of efficiency because the mass of the fuel source is reduced to zero. This is achieved by combining that mass, commonly which are made up of electrons, with an equal amount of antimatter, which cancel each other out, and this reduces the mass of the system to zero. Now that concludes our presentation on mass-energy equivalence, and hopefully you get the concept now. Thanks for watching.